Welcome back, everybody. We'll just allow a few more seconds just to let people board, as it were.
That's right. Now boarding group one.
Sorry we're a little bit delayed. We just came from Resolu's session. I know some of you were on it, and it's just so good. I did tell you that it's one not to miss. So I hope you got something from that. I always enjoy her sessions. Yeah. But, okay, so welcome everybody to back to the security stream, and we're now about to have Mark Nelson return to us for his session, Introduction to RACROUTE. So this is session 1 AJ, for the purpose of feedback. So without further ado, I'm going to hand over to Mark Nelson from IBM RACF Development. He's been with GSE for a number of years now, and I always feel, Mark, that the world of RACROUTE is a bit of a mystery. So I'm hoping you can solve that. And I hope you don't have imposter syndrome. Remember what Resli said? Name it.
I love it. That was a great session, by the way, for those who were able to attend it. If you weren't, I strongly suggest you watch the video when it's available and do the exercises. When she asks you to stand up and do something, stand up and do it. It really does make a difference. So again, Jamie, thank you for inviting me here to talk a little bit about topics that are of interest to, I hope, of interest to the RACF community. I'm Mark Nelson, a member of the RACF development team for 39 years, actually 39 years in IBM, member of the RACF team for 34 years. So I've written a RACROUTE or two, and I've gotten some of them wrong. This is part of our, imposter syndrome, I guess, acknowledgements, and that's okay because I figured out what was wrong and then I made them right. So that's what we're going to talk about here, this programming interface called RACROUTE. We're going to be talking a little bit about some other programming interfaces, where they came from, and well, I think we'll have an interesting time. If you have questions, please do ask. I'll try to get the chat thing set up, and if I can't, please do just interrupt me, unmute yourself, and that will be just fine. When I did the RACF update session, we fit it in, and I think it went 2 minutes over. This has a lot less material, so we can have a lot more discussion. I can spend a little more time on some of the finer points. So what is this thing called RACROUTE? Well, it's a macro, which means it's a programming interface, and I'll call it the primary mechanism, but not the only mechanism that resource managers such as TSO, IMS, CICS, DB2, whoever it might be, can use to make requests of the external security manager, the ESM, the external security manager. I hope everybody realizes there are three: RACF, ACF2, and Top Secret, all fine products. Those are the external security managers, and RACROUTE is the interface into all three of them, right? So first thing I'll point out is that RACROUTE is not a part of RACF. It's a part of the operating system. It's a part of ZOS, right? And it's the part called the System Authorization Facility, SAF. That's the interface between the operating system, resource managers, and that external security manager. Now, SAF consists not just of RACROUTE, but it also consists of other things like the callable services. I did say the RACF independent macros. That's kind of, we'll talk about what those are in a moment. In my mind, that's kind of a gray area. It's a little bit, but I've seen some documentation that says that, so I put it in there. It's also, SAF is where you'll also find the ownership of some of the key security control blocks that we have. So this thing called the Accessor Environment Element, or the ACEE, or the RCVT, right? The RACF Control Vector Table. Those really are SAF components, right? Things called tokens, those 80-byte values called U tokens, R tokens, S tokens. You see them in JES quite a bit. Those are in fact SAF constructs, and that makes sense, right? Resource managers have to have a common definition of these things across all of the ESMs. So those are also part of SAF. Now, there are things that are not a part of RACROUTE and not a part of SAF. And those are things I call provisioning, the definition of user IDs, or the definition of protection mechanisms, access lists, things like that, or grouping mechanisms, whether it's groups of users or groups of resources in member grouping profiles in RACF terms. Those are not a part of the SAF interface. Those are specific to the external security manager. Now, there are other programming interfaces. I said RACROUTE is one of the interfaces. There are some other ones. Init ACE, RAdmin, which you can use, programming interface for doing administrative kinds of things, RAuditX for logging, and RSec management operations, RSec Manager Opera. That's a new set of APIs introduced, I think, in ZOS v2 R3. They provide levels of service on top of what RACROUTE does. And in general, it might be better to consider some of those services rather than using RACROUTE if you have to add something to RACROUTE in your own processing. Right, so just be aware of that those services are there. They do more than what RACROUTE does, but many of them actually just end up calling RACROUTE after they've done some higher level function. And oh, by the way, there is another programming interface. I do not mention it here in the text, but I'll mention it here verbally. And that's the programming interface that's actually used to retrieve data out of the RACF database. It's a programming interface called Ichinty. It is not a part of SAF. It is very specific to RACF, ICHEINTY, I before E, except after itch. If you have trouble remembering how to spell Ichinty, right? But that's the lowest level programming interface. And in fact, that is called by many of the other RACROUTE request equals functions. We'll talk about what they are, or the independent system macros. So bottom line from all this is RACROUTE is one of the many interfaces you have to get things done from a security perspective. But for many different reasons, it is the one that most people think of when they think of what's my programming interface into the external security manager. So fundamentally, what is the job of the external security manager? It really is to answer one very, very simple question. Does this user have this authority to this thing? Does Fred have update authority to this data set? Does Anne have the ability to execute this KICS transaction? Right? That's fundamentally all that we're asking the external security manager to do. But there's a lot of things that have to happen under the covers to make that happen. Right? First thing is you have to have a label, a way of identifying users. That's a user ID. And if you have work that's coming in from somewhere else and it's not referenced by a user ID, it might have a digital certificate, for example. There must be mechanisms in place that allow the mapping of that identity, that digital certificate, perhaps that Kerberos credential, into an MVS style user ID, right? So that's part of the RACROUTE function. But fundamentally, you have to have a mechanism to identify who people are, who the ownership is for particular units of work. Right. Next thing you need to have a mechanism for authenticating those users to ensure that they are in fact who they say they are. Password phrases, digital certificates, pass tickets, and things like that, Kerberos credentials, those all come into play as being methods of authentication, augmented by multi-factor authentication. Great session this morning talking about the value of that. All of that comes into play, and all of that falls under the RACROUTE umbrella. The next thing you need is a set of attributes that represent the verbs, the things that someone is allowed to do. And in RACF, those are execute, read, update, control, and alter. There's also none. That's kind of you have none of those. You can grant that explicitly. And then you have to have a way of identifying resources. Now in ZOS and ZOS, the way one does that is resources are identified by a class name, like the facility class, terminal class, KICS-TRN class, whatever it might be, and a resource name, right, that will have a finite length, never more than 246 characters, but the type of class determines that length value. And then for some resources, you may have additional pieces of information that factor in. So for example, a data set, the volume serial upon which the data set resides and its unit will become potentially part of that identifying information of the resource. Or for a program, it might be the program name plus the data set in which it resides, plus possibly the volume serial, right? So that's the way of identifying resources. And all of those end up becoming part of the API, the application program interface, used to make access control decisions. Now, there are some other things that RACROUTE has. There are ways to optimize performance in a RACF environment and in the other external security managers as well. First off, I think all of us learned in Programming 101 class that I/O, input-output operations, are bad. And they're bad in the sense that if you can do things in memory, it's always faster by 3, possibly 4 orders of magnitude. right? So I always encourage that if you're doing something, reading data in, maybe if you think you're going to need it again, you stash it somewhere so you can get to it in memory. And RACROUTE has some ways of doing that for keeping information in storage. In particular, the preloading of security definitions in RACF parlance profiles. The preloading of profiles into storage. That's one classic way. That's a very effective way of improving performance as we are asking the question or answering the question, does Fred have access to this thing, right? Now, the other thing that we have for optimization of performance is that we have ways of taking that accessor environment element, that ACEE, and making it into a format where it can be moved into other places, either other places as in different spaces in or different addresses in the same address space, or potentially different address spaces, possibly even across systems, although there are a lot of considerations with that. And then they can then be reconstituted, sometimes people will say inflated, and become an accessor environment element. So instead of having to go through the whole validation process, if the environment and the application environment in particular has been set up appropriately and knows that it has taken the responsibility to properly handle the transference of identity from one place to another, then they don't have to go through the whole IO process of reading the RACF database to find the user profile and the group profiles and all that kind of thing. So that's we'll talk a little bit more about that in a few moments, but that's one of the examples of something one can do with RACROUTE. You need to have a mechanism to allow the recording of information about the access control request and the decision rendered by RACF. We sometimes call that auditing. In fact, the RACF books tend to call that auditing. I believe that's an inappropriate label. That's actually logging, right? The recording in an SMF type 80 record usually of something happening, that's a logging event, and auditing is the act of reviewing that log to make sure that your security policy matches what your installation security policy should be. I should say that the RACF definitions match what your installation security policy should be. That's one goal. And of course, second goal is to look for anomalies which might represent some bad things going on, nefarious activity from malicious users. As I mentioned, there are some things RACROUTE doesn't allow you to do. So the ability to aggregate similarly privileged users into groups, collections of users, or the aggregation of resources into a collection, if you will. Member grouping profiles is what I'm alluding to here from a RACF perspective, but RACF really doesn't have that. That's the responsibility of the external security manager. And what that means is the external security manager may provide, and in fact, they do provide some additional functions to handle those kinds of actions. Now, let's talk a little bit about history. As I mentioned a little in yesterday's session, RACF celebrates its 45th anniversary, or it celebrated it in September of this year. So happy birthday, RACF. In its original form, there was no RACROUTE. There were sets of what we now call the independent RACF macros, right? That's what we had in 1976 and what we were using internally prior to that. And these were macros like RACinit, which does identification and authentication. That's where you'd validate that users are who they said they were by the presentation of some credentials. And initially, it really was only passwords, and later on enhanced to have digital certificates, password phrases, Kerberos credentials, all that kind of stuff. RACinit is the interface, the independent system macro, which creates and deletes ACEE. So if you ever wanted to create that, that's what you've been coding. By the way, no one should be coding these nowadays. You should be using the RACROUTE equivalents. We'll talk about what they are in a moment. RACcheck, or I guess RACcheck is probably the right way to pronounce it. That's what you'd verify, you use to verify a user's authorization to a particular resource. So that's your authorization check. RACdef was used to define, delete, and modify resource profiles, and it did some specialized authorization checking that was really exploited by the RACF command processors. So if you use a RACF command to go and manipulate a profile, the odds are it's going to boil down to a RACdef operation, a RACdef invocation. We have rack list that was used to bring profiles into storage. And when I mean storage, in this case, it's not into a data space like the newer function does. It was to bring profiles into storage into the local address space. So then it could be used for FRAC check, right? FRAC check, which is an authorization check, which will require the use of profiles which have been loaded into storage. So that's how you get that performance benefit that I mentioned just a few moments ago. The rack stat macro would check on the status of RACF, is RACF active or not active, as well as reporting whether a general resource class was active or not active. And then last out of these is rack extract. And one would use that macro to extract or replace fields in a profile or in storage. And when I say in storage, I mean, it's like, get the current user ID under which I'm executing. You can use rack extract to do that. Any of the ones or any invocation of rack extract, which was actually going against the RACF database to read or write data, that will use that achinti function that I mentioned a little bit earlier and probably won't be mentioning much anymore. So that was the lowest level programming interface. Rack extract was a higher level extraction above that. So those are all the independent system macros. Several of these were implemented as SVCs, SV3s, 83, 84, in that series of numbers, right? So that's how this code worked. You would put these macros in, and boom, we do a supervisor call, and a ZOS supervisor call to actually do the function. Now, these services are designed and intended to work together. So, for example, you can't do a rack check, you can't do an authorization check, unless there's an ACEE against which we are going to do the authorization check, right? So you can't do a rack check without a rack init having been done by somebody. And the odds are that the somebody was, some part of ZOS, which as your address space was being created, will do that rack init, or its new version, RACROUTE request equals verify. We'll do that to set that up for your environment. But it is possible for authorized programs to do their own RACROUTE request equals verifies, their own rack inits, to set up task level types of security environments. Right now, that's one thing. They intended to work together and rack check requiring rack init. That's one example. But the other one that shows some interaction is sometimes one of these services will call one of the other services. So, for example, if you do a rack init, right, a RACROUTE request equals verify, if you're creating an ACEE for an environment and you pass in an application name, well, we're going to do an authorization check. So that rack init is going to invoke a rack check for the purpose of seeing if you're allowed to use that terminal or that application or whatever it might be. All right, so there's a lot of interrelationship and a lot of interplay between these various RACF macros. Now, it's been a long time, 1983, a number of years ago, RACF version 1 release 5, and that's where we introduced the RACROUTE macro. And the name really says exactly what it does. It's a router interface and intended to be a front end to RACF and to all of the other external security managers. We didn't want the other external security managers doing SVC screening or any kind of front ending like that. Let's create a generic interface where the name says pretty much what it does. It is a router. The request comes in, and then that request will get routed somewhere. It'll get routed to your external security manager. Now, virtually all of the enhancements that we have made since 1983, we have made in RACROUTE and not made available in the independent system macros. So if you're looking at things to do all that multi-level security stuff with sec labels and stuff like that, you can't do that. The interface does not allow that to be done in the independent system macros. You have to go out and use the RACROUTE macro in that case, right? So most of the enhancements are on the RACROUTE side only. And if you're looking at the documentation, we have an entire book, right? The RACROUTE reference manual, and there's an appendix that describes the independent system macros. So that should give you a hint. You should not be doing the independent system macros. I mentioned the B1 support. We did that back in RACF 1.9, MVS 3.13. And it really was a quantum leap forward in the security characteristics, security mechanisms on a ZOS environment. And it really required all of the resource managers, all of the folks who were calling RACF to change from those independent system macros into using RACROUTE. right? So that was really a change for lots of different components, not just RACF. So, all right, here's the Rosetta Stone. Here's the mapping between those RACROUTE request equals and the underlying independent system macros. So RAC init is a RACROUTE request equals verify. RAC check is a request equals auth. RAC def request equals define. RAC list request equals list. FRAC check request equals fast auth. RAC extract request equals extract. RAC stat request equals stat. Pretty straightforward mapping, and it's anything you could do in the independent system macro you can do in the RACROUTE version, but the inverse is not true. There are some functions that are RACROUTE only. Right, so there's a RACROUTE request equals audit, which will allow the creation of a sort of generic SMF type 80 record, general purpose security audit request. That is only available from RACROUTE. Ditto RACROUTE request equals DIR-auth. That's used for inter-process communication. We implemented most of these, or several of these, as a part of the B1 support, the multi-level security support in MVS 19, RACF 19, MVS 313. Request equals sign-on that manages the APPC, Advanced Program to Program Communication, PV, persistent verification, I think is what it stands for. Sign-on list, I could tell the number of folks who I've ever talked to about and have actually been using this on less than one hand. Request equals token build, token map, and token extract. These were definitely done for our multi-level security support, exploited quite a bit by JES. These build U tokens, access fields within that U token, or extracting U tokens from a current environment. And then the last one, request equals verify S. It verifies users and returns a U token. All of these are RACROUTE only functions, only RACROUTE functions. So I said these functions work together, and I mentioned that if you're doing an access control check, well, you need to have that validated identity. You need to have the accessor environment element, the ACE. What's in that ACE? The user ID, a list of the groups to which the user is connected. There's actually two of them. One's fixed at logon, and the other one can change during an authorization request. Any of the extraordinary attributes, special operations auditor, the U-audit attribute, if you're logging the actions of that user, application information, exactly how did this unit of work come into, what was the port of entry? What is and other information like that, and much, much, much more. So the ACE really is the security context. It is a thing which is most important. And early morning session today, we talked a little about ACE check, right? A new function we introduced, I think in V2R3, and rolled it back to earlier releases, allows you to detect if somebody is going out and manipulating bits in the ACE. It's not just a special bit, but there's a whole series of things. We don't tell you exactly what they are, but if somebody writes a program, has to be authorized, right? Writes an authorized program to twiddle any of those bits, well, lo and behold, the ACE check processing will flag you, and it can either warn you or it can stop the access control check. You can actually fail requests. Now, let's talk just a little bit about those ACEs, those accessor environment elements, because they can exist in a bunch of different places. And we sometimes refer to them as first party, second party, or third party RAC checks. And here's what we mean by that. A first party RAC check is where the external security manager figures out what ACE should be used for a particular request. So for example, if you say, does this user, the current executing user, have access to this? The first thing that is going to be checked is the task control block, the TCB, which will have a pointer to a security environment, or may have a pointer to a security environment. The concept here is it's architecturally possible to have an address space, which has an address space level identity, and each task within the address space has its own and different identity. It's not necessarily a great thing to do, but something was architected many years ago. So the external security manager will always look at the current executing task and see if there's an accessor environment element or an ACE pointed to from that TCB. And if there is, that's the one that will be used for the purpose of the authorization check. And if there isn't, we will then look at the one that's associated with the address space, right? So it's task first, then we look at the address space if there is no task level identity. We call both of those a first party RAC check. The ESM figures it out. The second one is a second party RAC check, and that's the one where you tell the ESM, I said RACF here, I really meant ESM. You tell the ESM, here's where I want you to use the ACE, right? It's over there at this address in storage, right? So the idea is that ACE got created by somebody, could have been created by the system, could have been created by you, really doesn't matter. You're just providing the pointer to it, and that's the one that will be used instead of the task level one or instead of the address space level one. Right, and we see this when resource manager will create free floating ACEs. Right, they're managing large numbers of tasks for users, and they have ACEs in storage for all of them, and they want to do the authorization check. They'll say use that one. Right, that's the concept of a second party. The third party check is one where you as the invoker of the RAC route, you don't provide the pointer to the ACE. You give RACF enough information so it can create that ACE for you. I said RACF, I meant external security manager, right? So you say, I want you to see if Fred has access to this thing, and you pass in the user ID of Fred or a U token that represents Fred. U token is that 80 byte sort of representation of a user, has a user ID, current connect group, and some other stuff in there. Or you pass in a group ID. You pass in any of those, and RACF is going to build an ACE under the covers, right? And then use that ACE for the purpose of doing an access control check. Now, interestingly, when you do that, RACF is going to place a pointer to the ACE that it just built in either the TCB send or the address space level one. And the rationale here is, hey, you asked about Fred once, maybe you'll ask about Fred again. And if you do, oh, wait, we've already built the ACE, so we don't have to go through the overhead of, doing the building of the ACE, which requires multiple reads potentially out of the RACF database, right? So RACF creates the ACE for you and anchors it in ACE3PQI. I can say RACF does that. I don't know if the other products do something like that. My suspicion is that they do. Now, these things called ACEs, they are control blocks. And those of us who've been systems programmers learned on day one that control blocks are a mixture of both data and pointers to other things which may have data or usually do have data. Right. Well, the problem with that is you can't move an ACE from one place to another because all of the addressing information in that ACE is going to be meaningless. It's going to be wrong, actually, when you move it to some other place. So there's this concept of the environment object, right? We call them environment objects. The RACF folks tend to call them RACOs for RACF objects. Now, the concept of the environment object is they're transportable, in quotes, and they can be reconstituted into ACEs. And I use the word flattened, and that's really what they are. We take the ACE and we change all of the data to which it points, we stick it at the end, and we change all the pointers to offsets. Right. So then the reconstitution process is just changing those offsets into addresses based upon where the environment object is being created. So that's the concept of a transportable kind of identity. The second one we'll talk about is that 80-byte encapsulation called a token. I mentioned that Jez uses them fairly extensively, and they have a couple of different variants. They'll have a U token, that's the identification of a user associated with a job. There's one called the S token, as different from the STOKEN, which is a Z architecture concept. The S token, if you hear somebody pronounce it that way, they usually mean this 80-byte thing in a Jez environment, which represents the submitter of a user or work, right? Or the owner of sysout, which is the R token. The R stands for resource. Now, there are cases that some of the RACROUTE interfaces will allow you to pass in the environment object instead of having to pass in the ACE. That's very useful. It's used rather extensively in some environments for RACROUTE request equals fast auth, that frac check thing we talked about. Now, one other thing I do want to point out that those environment objects, we will also store a form of them in the virtual look-aside facility, or VLF. This is a RACF specific thing. I don't know what the other ESMs do, but the concept here is if you're doing the building of an ACE for a user, the odds are you're going to build another one at some time in the near future for that same user. The design point of this, as I recall, was job submission, that during the job submission process, ACEs, an ACE for a particular user was created multiple times in multiple different places, sometimes in the JES address space, sometimes in the target address space where the job was actually going to execute. So, so in that environment, it made sense for us to cache things so that we'd have the ability to build the thing once, stick it in VLF, and the next time we needed to use it, potentially just a few microseconds or milliseconds later, instead of having to rebuild everything from scratch, boom, we could just pick the thing out of VLF. So that's all under the covers. You, as the invoker of RACROUTE, don't really have to worry about that, other than realizing that the values that you specify in that request equals verify will determine the handle, if you will, the values that will be associated with that VLF object. All right. So what does RACROUTE do? RACROUTE, its primary means of telling you what's going on is with the SAF return code, which gets returned in register 15. And there are three main values. 0, hey, everything is good. What you asked me to do, I was able to do. If it was an authorization check, the person had access. We'll look at 8. Right, that's the SAF return code 8. That means usually that you asked us to validate a user and create an ACE, and we couldn't for some reason. Perhaps you passed in a credentialing mechanism, a password phrase, or pass ticket that wasn't valid. SAF return code 8. You did an authorization check, and in the case of the authorization check, the person did not have access. So that way you find out is with SAF return code 8. Now, SAF return code 4 is the case where either RACF couldn't make a decision, right, because of something, well, basically you didn't tell us what the answer should be. So RACF, you have to tell us what the security rules are before we can say yes or no. And if there is no security rule, no profile defined that covers that particular request, then we're going to sit there and say, return code 4. What that means is no decision, and it's up to you, Mr. Resource Manager, to figure out what the right answer is. Now, in the earliest days, the usual rule of thumb was, well, if RACF didn't say no, then it must be okay. That's kind of what we use for data sets, right? Well, nowadays we're a little more paranoid. So that SAF return code 4 40 years ago, allowing access, in my mind, that's not appropriate now. You really want to have an affirmative access control policy where you've said what is allowed, and by default, access is not allowed. Right. So we see that more and more with more modern things. And by the way, by more modern, I mean things within the last 30 years. And then for some cases, like the case of data sets, there's seterops protect all fail, which will eliminate that SAF return code 4 for no profile and instead change that to a SAF return code. As I talked yesterday, we have a health check that now raises an exception if you don't have protect all fail enabled. Now, there is one other SAF return code. I often forget about this one because you have to be using something called list and execute forms of macros. We'll get into a little more detail later, but fundamentally the concept here is you're building 2 different versions of your parameter list for RACROUTE. One is a static version, and one is an executable version that might change as your program is executing. There's a length associated with each of those, controlled by the release equals keyword. And if they are not equivalent, you'll get this return code 64. And interestingly, interesting to me at least, the processing for determining if those parameter lists are equivalent, there's really not a call to RACF made. It's just in the macro itself, in the RACROUTE macro, there's some logic that compares two pieces of storage, and if they're not equivalent, it just sets the register 15 to hexadecimal 64. All right, so that's how you get the answer back. And that's the SAF return code. There's a RACF return code and a RACF reason code associated, and those will be in the parameter list that is being passed to the particular service. That's always pointed to by register 1 and you'll see it in the Balor. And we'll look at the code in a few moments. The values that go into each parameter list depend upon what service you're calling. So verify is different from request equals auth, as one would expect. There's also 2 parts to the parameter list that's being passed in. There is the SAF parameter list, and then there's a separate RACF parameter list, or function parameter list is, I think, how we refer to it. They are usually very contiguous in storage. They don't have to be. They have to be close to each other. I'm going to show an example of that. So the RACF return code and the RACF reason code you find in that parameter list, and any other information that's returned is really dependent upon the service that's being called, both in terms of how you specify it and how you find the information. Now, one of the things that is, I think, rather interesting about RACROUTE is everybody always assumes that you have to be APF authorized or supervisor state or running in a system key to use RACROUTE. And that's not true. It really depends upon what you're doing. Most of the functions you're doing, and certainly anything that is security sensitive, does require some level of authorization, either APF, system key, or supervisor state. But, for example, if you want to change your identity, hey, I'm Mark now, but I'd really like to be somebody else, that certainly requires authorization, as one might expect, right? So, but you have to look at RACROUTE, and in particular in the keyword definitions, to find out exactly what authority is required for a particular keyword. I know the MVS books usually have an authorization required right at the top of any of their descriptions of an authorized service. The RACF books don't do that. You really have to go through what's actually required by looking at each keyword. So just the way it is. So let's take a look at a RACROUTE request equals auth. I love sessions, by the way, where people have JCL. I see two slashes together and yay, right? Assembly examples, the same thing. So here we have a simple RACROUTE request equals auth. We're going to do an authorization check. So the RACROUTE macro requires a couple of different things. The first thing it needs is a 512 byte work area, right? You got to pass that in, and it's not shown here how it's defined, but just there's a DC CL512 somewhere in here, and the label associated with that is WORKA. So I load into register 2 the address of that, and now I do my RACROUTE request equals auth. Remember, authorization check. Does Fred have this access to this resource in this class? So the attribute, the value, the verb that we're looking for is update authority. The class we're looking for is the facility class. There is the ability to pass in 255 bytes of log string information, free-form information, put in there whatever you want. That information will show up in the SMF80 record. We do have an enhanced form that allows something longer than that. We introduced a release or two ago. Not seeing much exploitation of that. Kix is using that. But for the purpose of this, we'll just look at the old style logster, piece of information, whatever you want to have in there. Is what you put in there. The DB2 access control module, for example, puts in a whole bunch of information about the DB2 request. That is the source of their request equals fast auth. All right, but just 255 characters of whatever you think is important. Work A equals, in this case, open paren 2, close paren. That says the work address is in register 2. And we need to pass in the resource name that we care about. And I'm just going to point out that there are 2 ways of passing in this value: entity and entity X. We introduced entity X back in the RACF 19 timeframe when we expanded general resources from 39 characters to 246. And we recommend strongly you use entity X. If you use entity X, you have to pass in 2 half words of length information. One represents the size of the buffer, and the second one represents the size of the data that you're actually passing in. And in this case, I got lazy, and it's just 11 characters each, because that's probably the length of IRR.checkIt. This was a RACROUTE I wrote 15 or 20 years ago, playing with some utility things, right? But here's the length of the buffer, the length of the actual string, and then the string value itself. Log equals as is says, RACF, you do the normal default logging. Now, the resource manager can control what logging is being performed. You could say log equals none. Again, you have to be authorized to do that, which says don't cut an SMF80 record, right? Perform no logging. You could say as is, which says do the normal RACF defaulting, which means look at the profile, look at log options, all that kind of stuff. Look at the UAudit attribute. Or you could say log equals no fail. Log equals no fail says log only successes. And that's used fairly extensively in the RACF DB2 access control module. Decouple equals yes. I'm going to go a little bit on a side thing here. There are two other parameters not shown here. I apologize for not putting them in, and those are requester and subsystem, two 8-character values, right? The concept was when you wrote a rack route, since your code could be executing on different levels of the operating system, and in this case, it was MVS, right? Possibly even MVT. Geez, maybe. But bottom line, older operating systems that might not be running the same level of RACF, what you would do is you'd put a requester and subsystem in there, and there was something called the RACF router table. And you would update the RACF router table, or someone would update the RACF router table. IBM could do it, or you could do it for your own rack routes, to put in requester and subsystem and say, yes, I understand what this is, and I know how to deal with it. Right. Well, many releases ago, this became kind of cumbersome. So back in the RACF 1.9 timeframe, we decided that what we were going to do is put in decouple equals yes. Decouple equals yes says if there's a requester and subsystem specified, don't bother looking in the router table. And that just makes things much simpler. The other thing that we have in here is a release level. The release level will determine what parameters are valid, as well as what the size of that parameter list is going to be when it's actually submitted to RACF. MF equals, that's macro format. I'm using what's called standard format, which is, it creates non-reentrant code. For those of you who are writing exits or writing any kind of system level code, you would never do this. You would be writing reentrant code, which means that you would have a static version of the parameter list and a dynamic form of the parameter list. And the idea here is this would allow you to have one copy of your code in storage and as many people executing it at the same time. But this just makes the example a little simpler. So that's what a rack route request equals auth looks like. And I'll tell you, it's really not that bad once you get beyond the semantics of writing assembler. And yes, you can gen into assembler from Metal C and stuff like that. I haven't done that much. If somebody would like to do a session on that, I would be the first person to sign up. I think I've gone through exactly what all of these things are. I will just point out that if you don't put in a work area, that 512 byte area, RACF tells you with an OC4. And in my early days, I would leave this off so many times that I actually would recognize the PSW, the actual storage address. It was a low storage address, can't remember what it is now. But boom, that says I left the work area off. And I will tell you, I was led down the path to do that because the RACF books, the rack route manual in particular, has one chapter that talks about the parameters that are common to everything like release and work area, and then other chapters to deal with each of the other. So, request equals verify has its own chapter, request equals auth has its own chapter. So I'd open the request equals auth book, code up everything I thought I needed, and would never remember to go to chapter 2 to see the standard thing. So I got better with that. Recommendation on release, use the lowest level that has all the functionality that you need. We talked about decouple, requester, related. There's a keyword, related equals, which just lets you put some free-form text in. I don't think I've ever seen that used in the wild, but it is there. And that MF equal, macro format equal, standard, inline, non-reentrant, and then the other ones, list, modify, and execute. Only execute actually does something. The other two, list and modify, are used to create the parameter list, modify the parameter list, but you need to have something with MF equals E to actually cause something to actually happen. We talked about entity versus entity X. We talked about logster, the logster 255 characters, 1 byte length followed by data. Class is the class of the resource, 1 byte length followed by the data itself. Warning, 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 that's for request equals auth. Request equals fast auth actually wants an 8-character value. And at the end, I talk about some mistakes I've often made. That's one that I've made more than I want to admit. The concept here is I go out and I've got a request equals auth and it works great. I want to make it a request equals fast auth. So you change request equals auth, request equals fast auth, put a few other things in, right? And then it doesn't work. And you get a SAF return code 4, which says either RACF is inactive or the class is inactive or a profile is not found or the class doesn't exist. There's 5 or 6 different reasons, and it's kind of annoying. And true story, I'd done one of these, and I'd spent probably 45 minutes trying to figure out why my request equals fast auth, which I created from a request equals auth, didn't work. And sometimes you just got to talk these things out loud with somebody. So I step outside my office door, and the gentleman next to my office, smart guy, SDSF developer. And I said, yeah, I got this request equals fast auth and it's just not working. And he Oh, you can't, it's that stupid class equal. Sometimes you put a length and sometimes you don't. It's annoying. I'll just give you a heads up. If there are two types of RACROUTE coders, those who've made that mistake and those who are going to make that mistake. So just be careful when you're looking at class equals. Go out and see, do I need the length and then the data, or is it an 8-byte field that's right padded with lengths? And I talked about the various options on log equals, so we're good on that. Now, where is all this documented? It's in the security server RACROUTE macro reference. And as I point out, chapter 2 talks about the RACROUTE keywords that are common to everything. Chapter 3 is where you see the specific parameter information for the various functions. And then Appendix A, that's where you'll go out and find the independent RACF system macros, RACinit, RACDef, whatever it might be. And I don't know if I mentioned this, but when you code RACROUTE request equals verify, right? The SAF router gets control, the RACF router and then under the covers, we just do a RACinit. So it really is a front end router around the existing RACF functions. So if you were to go out and do that RACROUTE request equals auth that I showed here, that's where request equals auth. This is what you'd see created for the parameter list. Now, if you ever want to see exactly what all these bits and bytes mean, the place you need to look at is the security server diagnosis guide. That's where you'll find the actual parameter list mappings. They're actually very, very usable. They're pictorial in basis, really nicely done, and done probably 30 or 40 years ago. This top part here, that's the SAF parameter list. And in here, you'll find some length information about the SAF parameter list and some offset information that will point you to the function specific parameter list. So this guy will be the same for all SAF invocations. Its length will be determined by the release equals keyword. And then this guy here will be different for each of the functions. So request equals verify is different from request equals auth, is different from request equals fast auth. These also will have a length that is determined by that release equal value. If you do a standard format, this might be true for the list and modify formats, you'll actually see a little bit of, oh, didn't mean to go that far. You'll actually see a little bit of stuff in here. That's actually executable code, right? And the way this works is up here is your code. Then we have the SAF parameter list. There's a branch right here, right before the parameter list that takes you to this code, which then branches you around the parameter list. And we'll show you what that looks like by showing you exactly what the expansion of that request equals auth looks like. So this is the request equals auth. There's the MF equals S standard format. And the first thing, other than a little alignment thing that's done, is there's a branch around the parameter list. And in here, this is where you'll see all of the SAF parameter list information, message subpool, SAF return code, SAF reason code, the length of the parameter list. Let's see, there's lots of other stuff in here, not necessarily as well commented as I'd like to see, but oh well, such is life. So I think you see things in here like the requester and subsystem pointers to them, right? So that's your SAF parameter list. This guy branches around the SAF parameter list. And what do we have here? We have code. We're storing the contents of register 2, 24 bytes off of register 1. Well, register 1 is the SAF parameter list, right? That's convenient to know. 24 bytes into it is where the work adder gets stored. The address of that 512-byte work area address, which if we go back to look at that code, we'll see I said work adder equals 2. So that's how, why that particular piece of stuff got generated. Then the next thing we do is we do some work with the parameter list. Then we do a quick branch around that. And eventually, right, here we have this is the request equals auth. So it's the rack check parameter list. We see all the things that could have been specified there. You can pass in an ACE, an applicate. You can pass in lots of different things, user group, U token, R token information. But fundamentally, we're branching around all of that. That's what that val 1, star plus 96. We branch around all that. And we finally get down to the point where we're going to call the SAF router. And that is the Balor 1415 here. Lovely comment, branch to SAF router. Interestingly, there's a whole bunch of processing in here that looks to see, is the SAF router available? right? And what that is, there's an address associated off the CVT that represents the SAF router. If that address is 0, then there is no SAF router. Now, I've never seen that in the wild, and I believe you'll see that only if you are doing some kind of RACROUTE request equals something very, very, very early on in the, I mean, really early on in the IPL. There is an ISPF function, IPCS function that you can ask, which will show you the order of initialization in a ZOS environment. It's fascinating. You'll see in there that the initialization of SAF occurs fairly early on. The initialization of RACF occurs much later on. You'll see a module name, I think it's ICH SEC 05, and that represents RACF initialization. SAF initialization is done much earlier than that. So just giving you a flavor for what gets created. We have the SAF parameter list, we have the RACF parameter list, two separate things. They are usually located in contiguous storage, but they may have some things in between them. That's why we have lengths and offset information. So let's take a look at a different RACROUTE request. We want to create a task level identity for the user ID mark N. Well, that's a RACROUTE request equals verify and enver equals create. We're going to, in this case, in this example, say pass check equals no. So we are creating an ACE for somebody without regarding any kind of authentication. So you really have to be sure that your resource manager has validated somehow that mark N is really the identity that you want to create. You pass in that 512 byte work area. I actually left it in this example. And for the case of user ID information on a request equals verify, enver equals create, you do a 1 byte length followed by the actual data. And there it is, 5 bytes of mark N. This will, by default, create a task level ACE for the current thread of execution. So the address space identity doesn't change, but the task level one does. Task level one does. If I wanted to change the address space level one, I could do that. I'd have to specify ACE equals and point to things appropriately. All right. Now, if you've created an ACE, you really should delete it when you're done. And how do you do that? Request equals verify, enver equals delete. Enver equals delete. I strongly recommend, if you're ever doing that, always tell us exactly what ACE you want to delete. So you give us the address of the ACE, and in this case, it's in the variable WA_DFT ACE. I believe I took this out of the RACFDB2 access control module. Might have taken it from somewhere else. Decouple equals yes, release equals 2.4. Here we see MF equals E. This is the execute format of a macro. The assumption here is I have a list format somewhere else that will be in my static area and also my dynamic area, and I'm pointing to that dynamic area which has the label of RACF VERFD. Right, so that's just a way of pointing to where the parameter list is. This deletes the ACE and any of the related storage created by the ACE by any of the standard functions. Right, so if you've allocated some storage in a RACF exit, it's not going to delete that necessarily, but if you haven't done that, then this will delete the ACE and the U token and all the things that it points to. Big caution, big caution. If you point that ACE equals keyword to 0, or you didn't specify it, right? Well, we'll delete the task level ACE, but if the task level ACE doesn't exist, we're going to delete, I should say, the address space level ACE. We have a technical term for this. This is bad because you have an address space that now has no identity, right? And add-bends are usually the result of that because not everybody is able to cope with there not being an ACE for an address space. High performance requests. I mentioned earlier that IO is bad and we want to avoid that. So that RACROUTE request equals fastauth was created, and frac check the earlier invocation that says, hey, I want to go out and I want to do high performance checks because I can guarantee you that I have already, or somebody has already loaded the profiles into storage, better performance, and it allows you to do authorization requests in environments that you couldn't otherwise. So for example, if you're in cross memory mode, where your HACID, PACID, and SACID aren't the same, right? If that's the case, there's a whole bunch of things you can't do. One of them is IO. So lo and behold, you need to be using fastauth and these preloaded profiles. The other things, if you're in SRB mode is a very high performance way of getting work to execute in an address space. SRB mode also doesn't allow IO. So SRB mode or cross memory mode will require the use of these, of the request equals fast auth, and request equals fast auth means you had to have done a RACROUTE request equals list or setter ops rack list. Otherwise, what RACF is going to return is return code 4, no profile. Warning, warning, warning. There are many considerations for using request equals fast auth. And there's a chapter which talks, a section which talks about the difference between auth and fast auth, not just the class length thing. There are other operational considerations. It's worthy of a read. Now, how do you bring these things into storage? Here's a sample, also taken from the RACF DB2 access control module. RACROUTE request equals list, global equals yes. This was something new we did many, many years ago in RACF 2.1, not ZOS 2.1 or OS 390 2.1, RACF 2.1, where what we did is gave you the ability to do a RACROUTE request equals list into a data space. So the first guy, if no one has done it, boom, we create the data space. If somebody else does a RACROUTE request equals list for that same class, right, then what we do is we simply connect that address space into that data space. So it now has access to those profiles in that data space. And is there anything special here? Well, you got to specify as env create, the class name, give us the work area, decouple. Yeah, I always say yes nowadays. And you have to give us an ACE because we do put some control information into the ACE so that units of work in that address space can find the data space that has those profiles. Here's a sample RACROUTE request equals fast auth. You'll look at it and say, wow, that looks remarkably similar to a request equals auth. A couple of different things in here. The first one, as I mentioned, the format of the class equals. I'll give that to you as a warning at the end. Everything else is pretty much the same here, except for this guy here, ACEE ALIT. Right? As I mentioned, there are some services that support cross-memory mode, and this is how the request equals fast auth does that. If you have an ACE in a different address space, you simply give us the ALIT of that address space and the address of that ACE within that address space, and the request equals auth, fast auth will work just fine. We'll wrap this up. Here's our sample request equals stat. How would you check to see if RACF was active? Well, request equals stat, and I think everything else on there is a part of the standard SAF set of keywords. Work areas, requesters. Oh, I finally coded requester and subsys. Decouple equals yes, release equals. Yeah, all of those are part of keywords that are on every RACROUTE request. And this is the first time I showed you how to check the return code. Load and test register 15, and then branched not 0 to RACF inactive. Pretty straightforward. You can also do a very, very similar check and just simply give us in a class name. And we'll, instead of checking to see if RACF was active, which is what this was checking, we'll be checking to see if that particular class is active. And the only difference here really is a specification of a class name. So we'll wrap it up with a couple of gotchas. Be careful where you put RACROUTEs, right? And the reason why is that there will be serialization done, and the serialization depends upon what specific function you're doing. So really isn't an issue that much unless you happen to be putting RACROUTEs into RACF exits. Folks do it, but just be careful. You never want to get into a situation where you're doing a RACF exit and in that RACF exit, you're doing a RACF check, and we want to make sure that there are no serialization conflicts. So just do be careful there. And when I say NQs, I usually mean RACF NQs, but the other thing to point out is there's lock usage, specifically the use of the local lock. We document what the local lock implications are of each of these functions. You just have to make sure it's compatible with your use. Be aware that RACROUTE does expect standard OS 360 linkage conventions, so register 13 must point to a properly set up 18-word save area. Make sure that your release equals information is compatible, and by compatible, it really should be identical between your list, modify, execute forms of the macro. I banged out several times this concept of class equals has a different value for request equals auth and request equals fast auth. Don't waste your time. If you get the return code for and it's a fast auth or an auth, that should be one of the first things you think about. The ACE value is almost always the address of an ACE, except request equals verify, where it's the address of the ACE, the address of the ACE. Always check the staff return and reason codes, because if RACF told you something didn't work and you just continue on thinking that it did, you're not going to get the expected result. And remember that work area at that WRKA, the 512 byte work area. I've forgotten that. I used to forget it all the time. I've gotten better. But if you get an OC4 addend in low storage, that should be the first thing you think about. All right, so that's it for my stuff. If you have questions, we'll take a moment to answer them. Otherwise, email me or chat or find me somehow. I'll answer them. I love the fact that GSE supports the various charities. Jamie and company, thank you for doing that. You've seen the value of this. If you're not a member, become a member. And please do submit feedback. I love seeing constructive feedback, things you'd like to see added, deleted, what you thought of the session. This is how I get invited back, and I want to be invited back.
Thank you, Mark, so much for taking us through that excellent session. And the feedback, you hit on a very good point. So all the presenters, I mean, it takes, if you present it yourself, you know how much time it takes to get all these slides together, all the research and stuff. So please, it goes a long way when you can take the time to do that. But before we finish, if there any questions for Mark? You can unmute your line, by the way. I've enabled that. And Mark, like I said, excellent session. And remember what Resley said in her previous session. In your smile file, write that down. The positive feedback that you got. So own it. Don't brush it off.
Wise words. Wise words.
Yeah, if you didn't get to that, by the way, Resley's session, I'm sure Mark and Sue will vouch for this. You need to attend it. It was really good. There was good. I thought there was good audience participation in that. I took quite a lot of things from it. So I think there was a lot of honesty in the room, wasn't there? So yes. But Mark is back with us next Thursday. So that's Thursday at lunchtime at noon. And he's titled the session, let me remember this, Resiliency is Not an Accident. So I'm really looking forward to that. I haven't even seen the slides or anything, so we'll keep you in suspense there, but hopefully you can join Mark for that. Okay, so there's no questions. So up now we have a break until 3:30, and the next session on the security stream starts at 3:30, and that's with Isha Powers. And the title of her session is Trust No One. I'm really looking forward to that as well. So hopefully you can join that. Don't forget, folks, charity. Mark touched on it. If you can, if you haven't donated and you want to, please click on the Virgin Money giving link on any of the sessions that you see, and all donations gratefully received. But with that, thank you once again, Mark. Thank you everybody for joining, and see you in the next session.